Good morning. Good morning. Good morning. This is Mr. Henry Clement. Good morning. A very good morning from Mr. Henry Clement. This is the measurement class of the year 9. Okay, measurement. Measurements. Okay, or you can say measures. Okay, in your books, may write as a measures. Measures. Okay, so this should be the chapter 5 of the book, and this is weeks. This is our year 9, week 6. But your chapter 5. Okay, so today we are learning about. I think in the year 8 we are learning about length, how to measure length, mass, and capacity. For example, if this is an orange, okay, let's see if I have any oranges. Maybe I have oranges. Yeah, this is orange. Okay. So to this orange, do you know what is the length of the diameter? Okay. So for the diameter, maybe we should try to draw a line. Okay. So this one and here, yeah. Okay. So this should be diameter. Oops. Okay, this is diameter. Okay. So usually I think we can measure this in cm. cm. And roughly I think an orange is around 7 cm. 7 cm. Okay, this is a diameter. But be careful, if this is oranges, allow me to draw an oranges. It's not always the exact circle shape. And okay, so this will call the major length and this is called the minor length. Okay, for information, okay. But in our year 9, okay, we were not learning about this exact shape. We are just learning and think that this is totally a perfect circle. Okay, a perfect circle. Okay. Okay. Thank you for your greeting. Okay, I think I see the comment on the greeting there. And we shall go for we shall go for a strap. Okay, for example, this is a man who walk. Okay, maybe any. Is still this one? No, walking. Okay, now let me draw the walking one. Okay, so this is a man who was walking. Okay, and then this is the leg. And this is another one. So usually this length will be around 1 meter. So for this one, we can use meter and not 100 cm because this will give you a better idea. Okay. So and then we go to the mass. Okay, the mass here. Okay, well, about the mass, okay, we have the small item, we have the big item. Okay, for example, we have a car, transportation. We have a small car. Such as this, a small car. And then we might have no, this is not the one. We may have a people. This one. And we also have some food again. Maybe a big mangoes. Okay, so so if I have three units for you to choose between, one is called a ton, which is 1000 kg. We learned from year 8, and kg, and also grams. Okay, which one will you use to measure all these three? Okay, a car is usually 1000 kg, small car. So you may the proper one will, I think you'll see this is a 1 ton. Okay, so this for this one. And to measure the mass of the man or the boy, usually you know that it's about 50 to 60 kg. So the kg will be better. And the gram, a mango will be around 450 grams. So this one is better. Okay. So if you want to use the ton to describe the and a mango, so it will be like maybe about 0.0000450 ton. You see, this is too difficult. Okay. So then we need to learn about the capacity. For the capacity, okay, we need to know that 1 ml is equal to 1 cc. Okay. And this cc means that cubic centimeter. So it means that also 1 cm cube. Okay. So 1 ml is 1 cm cube. So if 1000 ml equal to 1 liter, so it's also mean 1000 cc or 1000 cm cube. All these will be equal to 1 liter. Okay. So today we need to learn one new thing, which is called, okay, CL. So 10 ml is a CL. So that means that 1000 ml is 1 liter, 1L. So 1000 you can split into 2, which is 10 times 100. Okay. So ml is 1 liter. So 1 liter is also this ml. This is 10. So this is 100 times 10 ml. And this ml will become like a CL. So I can change this one into a, sorry, to stick the line. Into 1 CL. So actually 1 liter will be 100 CL. Okay, CL. Just like our name. My name, Clement, CL. Okay, we should go to the area. Okay. So area is compared to, okay, this is 1 cm. And then area is like this one. 1 cm and 1 cm. It will be a 1 cm times 1 cm become a 1 cm square. Okay, this is about area. If this is 1 meter and this is 1 meter, so this one will be 1 meter square. Okay. So to this, actually 1 meter is also, okay, let's see, I'll add this to, okay. So same to this, okay. This 1 meter is equal to 100 centimeter and this one is equal to 100 centimeter. So when you come to this one, you know that 1 meter square is equal to 1 meter times 1 meter. So it's actually 100 centimeter times 100 centimeter. So it will be like 1, you have 4 0, you can see 1, 2, 3, 4. 1, 2, 3, 4, and then cm times cm will get cm square. So now you know that. Now you know that 1 meter square is equal to 10,000 cm square. Okay, you need to know how to learn to interchange between these two units. And then we will have this hectare. Okay. This is a very brief course. I hope that you need to learn and practice by yourself because remember the secret of learning, which is 9901. Okay, 99% is your own effort of learning, and only 1% will be my teaching. So to get 100%, you have to put in your own learning. Okay, this is the idea. You can always look as many teachers as you like. Okay, and maybe I'm the one of them. Okay, so today I'm introducing a new word which is called hectare. Okay. Hectare. This is one land. Okay, this is you. Maybe so small, right? Oh, I think smaller than this. Should be smaller than this. Okay, and this is 100 meter, and this is 100 meter. Okay, so 100 meter times 100 meter, we call it 1 hectare, which is equal to 1, you have 40 meter square. So applying the ratio method so that you can learn this one easily. Okay, I will show the method, which is 1 hectare equal to 10,000 meter square. Okay, if I want you to find 2.3 hectare, do you know how to find this? You should put a x here, and then from the x draw a arrow. This arrow is a ratio, so it's a divide. So your answer will be x divided by 10,000, x divided by 10,000 is equal to this one, 2.3 divided by 1. So your x will be 2.3 times 10,000. So your answer is 23000, 23,000. Okay. Yesterday we have show you how to use the ratio method. Always use this method ratio. You can solve up almost 90% of the question, no? Okay, because most of the question will be asking as a ratio and proportion. Okay. Then we go to the volume. Okay, just now we have one length, 1 cm, and then from this 1 cm we can become a 1 cm times 1 cm, you get 1 cm square. Okay, so now I want to make this 1 cm. Okay, 1 cm times 1 cm, and then we need to times the height of this thing. Okay, this is again another 1 cm. So this whole thing will become a one. Oh, how come so thin? Will become a 1 cm cube. 1 cm cube. So be careful with this measurement. Okay. So now we can have to see another one. This one. This one. And this one again. So if this is 2 meter or 2 cm, this is 2 times 2, and then this is 2, 2, and 2. So you can see actually this is 2 power 1, and this is 2 power 2, and this is 2 power 3. Okay. So the answer for this one will be, for example, if this is a meter, so it will look like a 2 meter. This is 4 meter square, and this is 8 meter cube. Why? This is because this is 2 meter power 1, 2 meter power 2, 2 meter power 3. Okay, allow me to show you something. Okay, the 2 meter times power 2 means that 2 meter. So the 2 times 2 you get 4, and the meter and meter you get meter square. So for the 2 meter power of 3 is like 2 meter 2 meter 2 meter. So the 2 times 2 times 2 is 8 meter cube. So this. Okay. Okay. So the problem of my iPad now is I enlarge, then it should be a problem. Then if I can make it smaller, I think that the thing will be look nicer. Okay. Okay, this is so-called volume. Okay, volume. Okay, now I think the question is not so easy because okay, they always involve this thing. They always involve an interchange between uh the units. Okay, something. Okay, so for example, if 1 meter, we know that this is 100 centimeter. If 1 meter square is actually 1 meter times 1 meter, so it's 100 centimeter times 100 centimeter. For your calculator, you know that this is 10,000 centimeter square. So just now I say you can use the ratio one to solve the question. Same thing, you can use the ratio to solve the cube one. 1 meter cube is actually 1 meter times 1 meter times 1 meter. So this one will be 100 cm times 100 cm times 100 cm. So you have 6012, yes, cm cube. So from here you can use the ratio to solve the question. Okay. So for example, if the question asks you to find 1 meter, then okay, to find a 6.3 meter cube. Okay. So you need to solve the answer from this one, from the previous one. So it's 1 meter cube is equal to 1 million cm cube. Okay. So if I want to find 6.3, so you use the ratio method, you can put the 6.3 here, and then you put the y here. So now you need to draw an arrow. Draw an arrow. This arrow is a ratio, so it's division. So your solution will be this y divided by 1 million equal to 6.3 divided by 1. Okay. So the y will be 6.3 times 1 million. So your answer will be 6,303, 6,300,000. Okay. So to this one is you can use in any way. For example, 1 meter cube is equal to cm cube. Okay. If you want to find for this, okay, for this, for example, how to convert 6,300,94 centimeter cube. Okay, then you can copy this one here there. Okay. Sorry, how to copy. Okay, this one. So you need to find this y. So again, you need to draw an arrow. Okay. So you need to know that y divided by 1 is equal to 6,300,94 divided by 1 million. So your y will be okay. To this, yesterday we also mentioned how to solve this question. So today we shall try. To divide this one, you can move 1, 2, 3, 4, 5, 6 until this is 1. So I need to move 6 also. 1, 2, 3, 4, 5, 6. So this one here. So my answer will be 0.630094. Okay. This is idea of calculate the volume. Okay. So, but actually, we will need to learn about this one as well. Okay. So, 10 cm cube is equal to how many liter? Okay. So, firstly, you need to know that this cm cube is equal to 10 ml. Okay. And then you know that from the other color, 1,000 ml is equal to 1 liter. So now a 10 ml is equal to X liter. So you need to draw again the arrow so that you can find X divided by 1 is equal to 10 divided by 1,000. So your X will be, against applying the method, 1, 2, 3, and then 1, 2, 3. So 0.01. Okay. So the answer will be 0.010 liter. Okay now. So is equal to 0.010 liter. Okay. So today I also will be introducing a measurement. Okay. Okay. So if this is a scale, okay, a scale. Allow me to see whether you have a scale here. No. Okay. Let me just draw a scale for myself. Okay, so I should draw this way. This is a plate, and then you can put your thing on the plate, and then this one later they will connect to the other thing, and then it will show you the, for example, this is a gram. Okay, this is a gram. Okay. This is a digital scale, okay? I think I should try another way. Okay, wait. Using the tools, I think it will look better. Cannot. This is a scale, and then this is the reading, and then there's a gram here. GRAM. Okay, gram. Okay, gram. Okay. So when I try to weigh something here, try to make it bigger. Try to weigh something there. Okay. So if I try to add on something, some powder, from flour. Okay, so if I add something here, the meter will start reading as 0.0, for example. If I try to add something on the top, even there is something already, even there is some flour on the wave already, on the waving scale, but you're still saying this as 0.0, okay? Until certain time that I drop one drop here. Okay, once I drop here, this drop by adding this particular drop, okay, suddenly the waving scale changed to 0.1. What does it mean? Does this mean that this particular flour with about 0.1 gram, and the other, all this thing is not waving anymore? It doesn't show that, right? Okay, it's just that when I add this flour, okay, and then suddenly the reading changed from 0.0 to 0.1. It means that what? Okay, allow me to show you this one. Okay, this is because this flour already, okay, 0.1 gram. That means that this is 0.1 gram, this is 0 gram, and this is 0.2 gram. Okay, so in between, we have the rounding up system. Okay, so it means that when I add from 0.001 to 0.00, okay, this is 0.05, okay, 0.02, and 0.020, okay, 0.021, until certain 0.0499, okay. Okay, this one will still round out to 0.0. That's why your reading you still read as 0.0. But when I add another small little bit of dot here, suddenly this one become a 0.0500. So this one is 5. As we know that, okay, to round out to 1, that means that we need to one decimal place. We need to draw a dot here and look at the next number. So the 5 we're adding another 10 here. Okay, so the answer will become 0.1. So the very moment of this dot adding it to the plate, to the waving scale, is actually the last dot of the, okay, before that was 499 and now it's 500. So it will be rounding out to 0.1, and then this is the lowest possible exact value of this reading. Okay, this 0.1 reading. Okay, so this 0.1 is ranging from 0.500. Okay, then you have this 0.1, and then until okay, let's see, I will add again. I add some more. So now it's here 0.501. Then I continue to add, and sorry, not adding this one, adding wrong thing already. Adding this. Okay, so I adding this one. Sorry, this is wrongly. I write wrongly. It should be 0.05. And then I add until 0.06, 0.07, 0.08, 0.09, 0.10. Yeah, it's the same. Okay. Now it's 0.1 already. But I still add something here. Sorry. I still add this one. I still add some more. Can you see the idea? I still add some more. This one is already exceeding 0.12, 0.13, 0.14, 0.14, 0.1444, And then I have 0.1499 is still appear this one as 0.1. Okay, now it's the weight of this one is 0.1499. Suddenly I just add another point here. Okay, and then this particular thing will make this one to become a 0.1500. Okay, because this scale is a 1 decimal place, so we took at 1 decimal, and then this is 5, so this will add to the 1, so it becomes a 0.2 already. So this does it mean again this dot help the scale from 0.1 to 0.2, which means that this is this dot is so heavy and the rest of thing is not? No, it's not, definitely not. Okay, so it's because of the rounding. Okay, so after this 0.1500, okay, so this one will become this 0.1500 starting from here. So the answer for this one is 0.1 is ranging from 0.05 to 0.1499. Okay, or you can write as 15, but this is not equal. Can you see? You don't have equal here. So it doesn't equal to this one. Actually, it just belongs to any number, any real number, which before the 0.15. Okay, so we call it. So when I see this 0.1 appear here, it does mean that from the very first beginning, this is the smaller part also become 0.1, which is actually the 0.050000. Okay, then you can write out this one. So we call it this is lower bound. Okay, lower possible value. And then on the other hand, this together with this everything in, okay, this is actually 0.149999, okay, which is less than 0.15. Okay, so this is so called the upper bound. Okay, so next time when I tell you 1 plus 1 is equal to 1, you know that this is from the lower bound, which is the red color, 0.05. Okay, or okay, allow me to show you another way. Okay, next time when I tell you 1 plus 1 is equal to 1, okay, you know that. Okay, the lower bound of 1 is actually 0.5. Lower bound of 1 is also 0.5, because once I add up to 0.5, then the machine will round to 1 if the machine is round to 1. So 0.5 plus 0.5, you know that this is 1. When I tell you 1 plus 1 is equal to 3, you may think that what teacher say is true, because the upper bound of 1, okay, if this is rounded to 1 digit number, so the rounded to 1, so it will be 1.5. Okay, not 1.5, actually it's 1.1.49999. Okay, plus and 1 also 1.49999. So if you round this one, is 2, it's near to, it's quite near lah. It's not exactly the same, but near to 3. So next time, if I tell you 1 plus 1 is not only 2, it can become a 1 and 3. You must know that this is true in mathematics, and this is also true in this measurement. Okay, so hope you enjoy this class. This is Mr. Henry Clement. Okay, hope you enjoy our class, and we will be having some short definition course for the year 10, 11. Okay, please help us and like us and motivate us, okay, and share us, so that we can have the motivation to move forward. Okay, so if you need anything, always comment, always like and share us. Thank you very much. This is Mr. Henry Clement for your year 9 math. Thank you very much.